You're watching the What's New with MotionWorks IEC3 video series. In this video, I'll demonstrate and explain the Optimize Axis feature in hardware configuration. Hi, I'm Matt Pelletier. Here's a quick preview. In hardware configuration, there's an optimization tab for each axis. Click the button to calculate and set tuning-related parameters to their optimum value. These values cause the servo motor to respond more smoothly, reducing torque ripple and motor heating. Now let's look at this in more detail. Optimize Axis is available for all controllers in the MPIEC platform. The feature was introduced in MotionWorks IEC version 3.3, and I am using version 3.3. If you select one of the axes in the hardware configuration tree, you will see the Optimization tab. When you click the button, Optimize Axis, it sets the feed-forward gain to the maximum of 100%. The time constant is set to match the mechatronic cycle, in this case 2 milliseconds. Velocity feed-forward is disabled, and an S-curve acceleration filter is applied with time constants also set to match the mechatronic cycle. So why bother doing this? Feed forward helps reduce position error, as explained here, especially in applications with high acceleration rates or those following a cam or gear master, when the position error must be extremely low. The other parameters help reduce torque ripple and motor heating. There is a recorded webinar on our website that discusses this in detail, but let me make a summary here. The top 3 parameters in this list all relate to velocity feed forward. Feed forward takes the speed of the position command as an input to the speed loop and results in reduced position error. The amplifier internal feed forward gain and filter result in a smooth response because they operate at the internal update rate of the amplifier. The controller feed forward operates at the mechatronic cycle, typically around 2 milliseconds. After the servo is tuned for high performance, the response to the controller feed forward can result in many small jumps at every mechatronic cycle. Each jump produces a surge of motor torque, resulting in higher torque ripple and motor heating. Therefore, the controller feed forward is disabled. Even without controller feed forward, the controller position command is still received at the mechatronic cycle. A servo motor tuned for high performance can respond very quickly, producing torque ripple at this rate. The command can be smoothed out using a filter selected by parameter 1311. This distributes the position command over the mechatronic cycle. The servo pack internal position loop receives the filtered position command, resulting again in smooth motion with low torque ripple and reduced motor heating. Now I'd like to demonstrate the effect of the Optimize Axis feature using 2 motors on the standard MP3300 IEC and Sigma7 demo. The Sigma7 W amplifier runs 2 identical motors with identical loads. On the left, the X-axis has been optimized for performance in hardware configuration, and on the right, the Y-axis has not been optimized. The MP3300 IEC is programmed to command the same cam profile on both axes. I'll show the result of the tuning process using traces taken from our software Sigma7 Plus. By default, the servos are in the adaptive tuningless mode, and you can see the 2 traces are about the same. The position error of the optimized axis is actually significantly higher than the original not optimized axis. But here's the result after auto-tuning using mode 2, designed for point-to-point positioning. You can see that the basic response is still the same in terms of position error and settling time. Looking closer, the optimized axis has virtually no torque ripple, but the other axis has very high torque ripple. This is because the command is not filtered, and the controller feed forward is still applied at the mechatronic cycle. Here you can even see that stair-step appearance in the command every 2 milliseconds, corresponding to the mechatronic cycle. Compare that to the result of auto-tuning using mode 1, which is designed for low position error during the entire move. For both optimized and not optimized, the position error is 0 during the move. The optimized axis has positive error during acceleration to the amount equaling about 4 degrees. The axis that is not optimized has too much feed forward, resulting in negative position error during acceleration. The motor is actually being pushed ahead of the command in this case. The unfiltered command produces extremely high torque ripple, and looking closer, it's easy to see the difference. So we hope you find the Optimize Axis button very convenient, and we recommend you use it for every axis with MotionWorks IEC version 3.3 and later. Thanks for watching this video, and go to yaskawa.com/IECSW to download the latest version of MotionWorks IEC 3.